Hello, Dr. Fadon. We are the Tenneco Plant Layout Project Group, and we are Justin Brown, Eric Moss, Eric Taylor, Grant Jenkins, Ahmed Atala, Austin Ochi, and Zach Armour. So for this project, our goal and methodology is to increase productivity by 5% plant-wide, ask questions, understand the problems, ask more questions, gather more data, question the data, evaluate and analyze and improve.
This graph currently on the screen shows that Tenneco currently has 5 operators that do 6 different jobs. There was a significant amount of idle time in their work. Their takt time was 128 seconds, and their individual work was barely above 60 seconds. We were able to show by combining tasks and operations that we can get down to 4 operations with 3 operators.
So if we look at this chart, it's the current material flow state, and it shows how the materials are moving throughout the lines. Currently, they're very spread out. There's bottlenecking that occurs in certain areas, and some of the processes are even repetitive. And then looking at the operators' movement states on this chart, we can also see that the operators are spread out across, but there's still bottlenecking that occurs. There are operators that do too much walking across the lines, and there's a cramp pitch. So our improvement roadmap is to move 1 operator to the robot cell instead of having to get with quality on converter QIS, move bolt up gauge, combine both gauge jobs to 1 operator, and move welder materials to welder booth area.
With this current graph that's shown on the screen, it shows the future productive state, which has 3 operators with 3 jobs. This graph shows the increase of productivity and improved cycle time. The important part is that the data showed we can still be under takt time and indeed repurpose 3 operators.
This diagram has a lot less movement than the original one, and the lines are very much cleaner than before. There's increased accessibility, and there's no repetitive processes. It also looks a lot better because there are only 3 operators instead of 5. This diagram is for the operator movement state, and there's concentrated workstations, increased cycle time across operators to decrease wait time, and the total steps decreased from 78 to 45, which was pretty close to half of what the original amount of steps took. This is a comparison of each, and the top is the old, which had 5 operators, and the bottom is the new and improved, which only has 3. And as you can see, the bottom is much cleaner and the flow is a lot higher.
So this is our cost reduction chart we came up with. We ended up saving $136,278. So, and that would be the biggest part is the cost savings and our results. So we arrived at this figure based on reduced labor cost per part, per assembly produced, and annual demand, as you can see on the table on the right. And we'd like to thank everyone involved for the project, and any questions, you can just ask us personally.